Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Welcome back to, or welcome to, if this is your first time, the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this show that we designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, please visit digitalenterprisesociety.org. My name is Thom Singer, and I have the privilege to be the co-host of this podcast, along with Craig Brown, an industry veteran and former PLM leader at General Motors. Hey, Craig, how are you today?
I'm great, Tom. Happy New Year. 2020 has made it here. Another decade has started.
That's right. I think this is like maybe our second show of the year and maybe third, and we are keeping this thing going. We kicked off, I think, around June of last year, and we're going strong. The listenership is growing, and we're getting some pretty good feedback about the show. So cheers to you, Craig.
Well, thank you. Likewise to you, Tom. It's nice doing this. It's fun. In about 20 minutes, you can hear about something that's on somebody's mind around digital transformation. And today's guest I'm looking forward to speaking with. It's a little bit of a different twist on what we've been doing, so it should be a lot of fun.
Yeah, well, each week we try to bring to this show interesting interviews and other ideas that are going to help all the listeners enhance and grow their careers. And today's going to be great. Today we have with us Daniel Campbell, and he is the Director of Business Development for Capvidia. Hey, Daniel, welcome to the Digital Enterprise Society podcast.
Thank you, Tom. It's nice to be here today.
Well, we're glad to have you. Daniel, what's your background? How did you get into this crazy world?
Yeah, well, so my background is, it actually is in the field of simulation of coordinate metrology, so CMM machines. Me and a couple of my early business partners created a product called Pundit CMM, which is a offline CMM simulation tool to basically carry out a simulation of a CMM measurement in order to calculate what the measurement uncertainty is going to be for everything that's being measured. And the measurement uncertainty, that's basically, you could think of it as the plus minus value that you would get for each of your measurements. And so that is, that's my background, and that's really what brought the world of model-based definition. We, as metrology software vendors, we really felt the need for model-based definition data. I mean, it would have been a big thing for us to be able to get some of this MBD data to make sure that the people who are using this simulation software don't have to type in data again that's already entered into their CAD system. So that kind of brought us into the whole CAD world and PLM world.
And then how did you get to Capvidia?
And so Capvidia acquired the Pundit software about 3 years ago. And when that happened, I came over with Capvidia. And since then, I've kind of taken over the operations of trying to grow the business, not only just with the Pundit software, but really focusing a little more broadly on model-based definition efforts. Because I think that it's kind of put us in a really unique position where we really do bridge the gap between a good understanding of downstream applications like metrology applications, and then the source, the CAD data, the CAD and PLM data, which is always what Capvidia's background is.
Yeah, and so this is really important, everybody, and it's a hurdle. That's part of why we wanted to talk today. A lot of times, the people that have started using CAD, especially if they're replacing drafting operations, it's all about just let's get the model put together, and then those guys in simulation, and I'm talking about physics simulation, not measurement simulation, can go off and do what they need to do to figure out if the design's robust. You're looking at a different problem, which is the machines that are on the manufacturing line, they're taking measurements, and if I understand it correctly, you're simulating uncertainty and whether those measurements are accurate, and then what's that effect on manufacturing? Is that right?
Exactly. Yeah. When it comes to the Pundit software, I mean, the point of what it's trying to do is understand, the measurement system that I'm going to use to measure and validate this part. Is it adequate or not? Am I measuring this thing correctly or not? Can I trust the numbers that are coming off of my CMM machine or not?
Yeah, and a lot of times there's a standard on a part, a finish standard or a milling standard, and you wonder where that stuff comes from, and it's probably proven over time, at least at somebody like a car company, it's proven over time. But my point is a lot of times there's things specified that you can't measure. And then you figure that out later that, oh, wow, at this line rate, there's no way I could measure that accurately. And so I think that's where you guys come in. You can help say, well, this will be great, but we don't measure that way, or you need a different kind of instrument if you want that kind of precision.
Exactly. I mean, what it all boils down to is basically the GD&T, the geometric dimensioning and tolerancing, which is placed on part. So yeah, if you're going to validate that, you want to manufacture to that, and then you measure to make sure that the actual manufactured good does meet those GD&T requirements. Yeah, hopefully you have the manufacturing capabilities and the measurement capabilities to meet the tolerances that are specified at the design state.
Or go the other way, make it clear to the designers, don't specify something that has to have that tolerance, right? If I'm a big, successful industrial company, I have my current practice for measurement, right? And milling and all the rest, right? So why would you design something I can't do? So it's capturing the bill of process, if you will, of manufacturing, including measurement, and making it clear upstream, well, design parts that are within these boundaries. And I think this is where simulation is, it's one of its biggest benefits, is it can show you how soon you get close to a boundary. Right?
Absolutely, yeah. And actually, really, the entire field of model-based definition, that's what it's all about. I mean, so the current state of sort of a law manufacturing enterprise really is that the design side of the house, the design engineering side, is really pretty separate from the manufacturing and measurement side of the house. And so this type of communication that you're talking about, it doesn't really happen right now.
So why are they separate? What's your insight there?
Well, so organizationally, first off, they are typically separate business units. Some companies might have design, engineering, and manufacturing in the same group, but it's usually pretty typical that they actually are separate business units. And then the other thing is just in terms of their software systems, they're quite different, quite separate. On the design side, you're dealing with PLM software and CAD software, and then on the downstream manufacturing side, you have a huge number of different software systems that are used for all the various manufacturing and measurement and assembly and MES and all these other processes which are carried out downstream. And theoretically, they need to consume that CAD data or the PLM data. But often the handoff between those two domains of these different software systems is really not very good, especially when it comes down to detailed level about the part, like the geometry of the part, like the GD&T on the part, and so forth.
I know a lot of us, in my experience, you keep going to a big tool vendor, and you say, oh, surely you've got an end-to-end solution. And of course, the sales guy will always say he does, right? and then when you start plugging it together, you find out, well, it's really great at one aspect of engineering or manufacturing engineering, the planning of manufacturing, but not so great at other aspects. This dichotomy of tools, or having separate tools, also leads to I think that organizational thing you pointed out about, well, then the guy up front where the MBD data probably should be entered sometimes doesn't see the value in this downstream information that they've never interacted with before. So how do you get them convinced they should put in the GD&T and other such things?
Yeah, no, that's I think that's an important part of it is trying to deal with the people side of it. Sometimes there is a business problem in the sense that the budgets for manufacturing and for design are separate budgets, separate business units. And so on the design side is where the cost would be for adding or for creating model-based definition. But the benefits are the manufacturing side, more or less. And so that's part of the struggle often, is trying to deal with that. Now, as it turns out, the answer to that is that the benefits are not all on the manufacturing side. First of all, it's been shown that for engineers to be able to view data in 3D, that there are tangible benefits from that as opposed to falling back on the 2D drawing. But then the second thing is that there are solutions that can take advantage of model-based definition that design engineering can take advantage of, like tolerance stack-up analysis solutions and things like that, virtual assembly.
Yeah, in the car business, if you had a noise problem, so some kind of rattle that you don't know what it's due to, that's when those tolerance guys and the stack up tolerance, they can hit a home run, right?
Absolutely.
Usually what happens is it worked fine for, several products, maybe even several thousand products. And then all of a sudden something happened, and it's typically, maybe it's a material change, but something happened where the same drawings, the same instructions, the same manufacturing, and now we got a rattle developing, right?
Mm-hmm.
And especially in today's car business, rattles are terrible, right? They customers get really unhappy and they don't buy your thing the next time around.
Absolutely. Yeah, it's a big thing. And I mean,
so my point was, you look for those opportunities, and then everybody all of a sudden realizes, oh yeah, if we'd have put that information in up front, I understand the importance of it now, and it's to make sure this warranty problem, that's what we would have called it, doesn't show up in the future.
Absolutely.
So the tolerance is broader, if you will, so it can handle that.
Yeah, and I mean, a simple example of a type of let's say a tool chain that could take advantage of model-based definition, where feedback would be back to the design team, to the benefit of the design team, would be model-based definition placed on the part up front by the designers. Parts start to be manufactured. You're measuring real data on the parts. You take that data from the real parts that are measured, and you feed that back in on the design side to your tolerance analysis, do basically a virtual simulation or a virtual assembly of your part or of your product, and you can see, okay, how are the parts that I'm actually manufacturing, how are they actually fitting together? Not just in theory, how should they, but how are they fitting together? And you can make adjustments based on that. I mean, that's really, when we talk about virtual or digital twin, that's really, how you go about doing it is with technologies like these.
So you're hitting on one of my favorite topics as I was retiring, and it was okay. So you talked about how the assembly of it. Do you also consider the dynamic performance? So when the particular system, I'm thinking like a chassis component, is dealing with a bump in the road, do your simulations also comprehend that maybe the parts move relative to each other and they still need to perform properly?
Yeah, I mean, I think that type of thing is taken into account by some other tools out there. So our software is not in this area of tolerance analysis. I mean, really, what we try to do is provide technology to glue together different software tools using model-based definition. I mean, we really try to focus on standards, international standards that are out there, like the QIF standard, the Quality Information Framework standard, or STEP AP242 standard. Mechanisms like this for transmitting data across your domain or across your enterprise, across the various domains, the part geometry information, the GD&T information, and so forth.
So computers are getting faster and faster, and they're more capable, and they got all this memory now sitting up in a cloud. Are people also seeing a benefit through automation? And if so, could you describe that? I mean, what kind of industries are adopting it first due to automation?
Yeah, no, I think that this is the time that industries are really starting to take advantage of automation. There are so many different software tools out there that are doing some amazing things, and now by using a lot of the standard data formats out there, it's possible to piece these systems together so that they can kind of operate autonomously. I mean, it's actually pretty amazing getting involved in detail with a number. So yeah, our customers are all across the different markets. It's like automotive, aerospace, and defense, medical, and consumer electronics, and it's really cool seeing how in each of these domains, the extent to which so many operations are still manually driven. And things that boil down to just simple data transcription. I have to take this data in this system and type it into that system, and then press the go button, and that's it. And so those are all what I would consider to be super low-hanging fruits. If we could figure out a way that the data from this system could go to the data from that system without someone have to type it in, there's an automation that you just enabled.
Yeah, and I heard an interesting talk. This is tangentially related, but I was bringing up this issue of data silos, and the gentleman was one of the technical leads at IBM, and I asked him, So will machine learning and automation like that help solve the connection of the silos so this transfer could be automatic? And his eyes lit up, and he said, well, the machine learning community is beginning to realize what a huge opportunity that is. So, take a step back for a second. You think we'd all get into one common system, the data would be consistent, the glossary, if you will, would be one, and then people would all of a sudden get all this benefit, right, from automation.
Mm-hmm.
Instead, you mentioned it earlier, because of organization, you got silos.
Mm-hmm.
And then the language each silo uses is slightly different. And so it's kind of a mismatch.
Mm-hmm.
And so you get this transfer point that's typically human generated because of all these mismatches. And I think it'll be interesting to see if it happens. But if machine learning solves this Tower of Babel problem, getting the two silos to talk, well, then all of a sudden the clerks needed to move data from one system to another can go do more valuable work like design or manufacturing or whatever. So
yeah, much better value added work. And you're right. I mean, once these communication barriers get broken down, the amount of raw potential in terms of machine learning, like you're saying, is massive. I mean, it's basically, there's every machine that you find throughout your throughout your manufacturing enterprise outputs tons of data, raw data, all day long, every day. But most of that data is just thrown away because it's in some proprietary format. It's not connected to the the single source of truth, your CAD system or anything like that. And so the idea of being able to take this data and actually use it in some way, I mean, as people start to figure that out, there's a lot of potential that could be unlocked with this.
Well, and I think we talk about the terms digital transformation, and this term digital twin has come up a couple times in previous podcasts. I think at the end of the day, they all sound like copies of information, right? And you really want to get back to views of an information pool. Some people call them data lakes. And the view is what you need in order to make a decision. And whether it comes from one or more systems shouldn't matter. And of course, if it's annotated with simulation of performance and simulation of how you manufacture it and measurement, so much the better. Daniel, one of the ways you are a member of the Digital Enterprise Society is through your subcommittee work. Could you describe a little bit which committee you're on and what you guys hope to achieve here in the Digital Enterprise Society?
Yeah, I'm on the education subcommittee, which is led by Rosemary Astheimer of Purdue. And there are a number of ways in which the education committee is trying to improve the outreach of the center in terms of educating the manufacturing industry about some of the modern trends in terms of technology. I mean, technology moves so fast, and so one of the areas that I'm focusing on in my working group is in the area of model-based definition, and there's kind of been a big emphasis on QIF, the Quality Information Framework Standard, which is an MBD standard, especially focused around measurement-related tasks, because it's kind of a big up-and-coming standard, and a lot of people are talking about it, and I think a lot of people are wondering, what's it all about, and for me, and so forth.
Well, that's exactly what we did when we created the Digital Enterprise Society. Is we wanted to address these emerging trends, and we wanted to help people understand how first to learn them, and then second to understand how it fits into their job or into their career. There's always a lot of fear when something new comes along, and there's people like probably all of us that we embrace technology. That's why we get ourselves involved in things like this. But then there's a large group of people that it took them a while to learn what it is they do, and now you're telling them they got to relearn again, and they really get scared. To what degree can we help the fear side of this?
Yeah, it is a tough thing. I mean, because manufacturing, to a large extent, I would say is behind some of the other fields in terms of its current adoption of technology. But that seems to be something that, at least to me, seems like it's changing fast right now. Like the last 5 or 10 years, things have been really picking up in terms of adoption of really advanced technology. But I think that, I think a lot of the fear has to do, number one, with just having to learn new technologies. But But as far as that, I think there are great organizations like the Digital Enterprise Society out there that can help people get up to speed with some of the modern technology. The other thing is that people shouldn't rule out talking directly to the software or technology vendors about some of this technology, because I mean that's kind of a large part of a technology vendor's job, is to educate the user base about, how does the technology work, what is it for, why, what are some use cases, things like that. I mean, so that's something that is actually a very ordinary part of what I do on an everyday basis.
Well, and I think it's really good that you do it. And I think one of the things that both the vendors and others, you need to learn from all this is also understand your problem domain really well, right? That way you can figure out if there's a match between the use cases the vendor's talking about and the use cases of your company. One of the other topics I'm reminiscing about we've had over the last 6 months is about how manufacturing itself is going to change, not just the tools that help it, but the fact that we'll go from milling and bending and drilling parts to printing them, right, through additive technologies. And so I think that's another set of changes that's coming. Well, fear and ignorance just lead to obsolescence, right? And so you need to embrace it. You need to figure out what's real and how it helps your company. And the best thing to help your company is really understand what your company does, right? The notes you and I exchanged beforehand here, you mentioned a lot about the companies that chose not to adapt, right? And
that's right.
Kodak being one of the better ones. And yeah, where Kodak, some of the people that did the film technologies, how you make the Mylar and all the rest of this stuff, those folks are now of all things in businesses with membranes, so chemical plants and people that do things like fuel cells. So it's just interesting where they ended up, right?
Yeah. It is pretty amazing to just look at some examples of some of the big companies that were just dominant in their age, but within just a matter of a few years, they missed the boat on some technology and they become historical anecdotes. It's amazing. Yeah.
And my point to all the listeners is, you as individuals, you'll still be very employable if you're willing to adapt and learn, and whatever it is your expertise is. In this last case, I was using film engineers. There'll be other industries that'll need it. You just have to keep your eyes open and be ready to go try something completely different. So
Yep.
Anyways,
There's definitely a little bit of a learning curve, but I mean, it's that's really the extent of it. I mean, there's always so many people out there to try to help. And you can look at the exciting part of it. It's a lot of it's fun technology, and it's cool to see it come into place and see how things evolve.
So Daniel, this has been a very interesting conversation. I hope folks you've picked up on the importance of simulating measurement in the factory. And with that, I'll hand it back to you, Thom.
Thanks. Hey, Daniel, before we let you go, I love listening to these conversations because Craig always gets very technical with everybody, but you guys kind of got into an area that's sort of my area of expertise, and that is helping the listeners of this show really focus on growing their career. And you brought up something that I teach people to do in my line of work, and that is reach out to your vendors for education, right? We sometimes think, oh God, the vendors, they just want to sell to me. But the reality is that the vendors don't just work with your company, they work with a lot of your competitors, a lot of ancillary companies. So in thinking of that, what career advice do you have for people who are looking for ways to grow their career and look for maybe, they've got to look for a new path? How do they reach out to the vendors, and what should vendors be really teaching their customers?
Mm-hmm. Yeah, no, I think it's a good point. I mean, it is true. I think lots of times people look at vendors and they think, oh, I don't want to talk to that person because then a salesperson will have my info and they'll just bother me. But really, I think the majority of companies aren't like that. I mean, most of what, even for our company, even for our sales team, it's about, learning what is it that the customer needs, understanding what their pain points are and forming products that fit those pain points and delivering them. And I would say most of the technology vendors out there are like us, that we focus on creating technology. The fact that we have a sales team is sort of in support of our core technology team, which is creating it. And so I think the easiest way to reach out is just simply to reach out. And it's it's perfectly acceptable to reach out and say, look, I'm not really in the market for purchasing anything, but I was wondering if I could have some more information. I think people would welcome that, and at most companies, I think they'd be totally open, and they'd love to have a conversation about this stuff. Because at the end of the day, you got to remember, and I think it's the same with other technology providers, we are super passionate about what we do, and we love talking about it. So just as a fun thing to have a conversation, half-hour conversation with someone about our core competence, it's fun.
Well, plus,
if I could add, and I always appreciated the suppliers, the tool vendors that were a part of organizations like the Digital Enterprise Society, because you're reaching out beyond just that point of sale to, no kidding, trying to influence policy and maybe the adoption of standards, which I think is excellent. That is what works long term. That's how you leave a lasting effect.
Absolutely.
So thanks again for joining us in one of our subcommittees.
Yeah, I mean, I always think one of the secrets that I tell people is that if you're in the market for a job, or you think maybe I could be in the market for a job, realize that the vendors who sell to you, they know who's looking for good people. And so it's like sometimes you and I were joking about it, Daniel, that, oh God, they're just going to put me on a mailing list or whatever. But in reality, if you look at those people as a peer who can really go out and help you, when you confide in them and say what's out there, they often know what's out there. And they want to help place you, because then when it comes time to buy the technology, you're going to feel like you have a connection, a friendship, a kinship with them. So I'm glad we touched on this, because I think that's a point that people overlook all the time.
Absolutely. Yep.
Well, thank you so much for being a guest here on the Digital Enterprise Society podcast. Any last words, Daniel?
No, just thanks for having me. It's been a lot of fun chatting with you both.
Awesome. Well, and thank you to everybody who tuned in and listened. Please join us next week when we're going to have more thoughts, ideas, and information in and around product lifecycle management. The Digital Enterprise Society, it is the place for the exchange of ideas around digital manufacturing tools. Check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.